Welcome to video number 4 for this unit on one-variable statistics. In this video, we're going to focus on manipulating data. We can describe the variability of a distribution using the standard deviation. The standard deviation is a measure of variability that is calculated using a method that is similar to the one used to calculate the MAD, or mean absolute deviation. For now, know that the standard deviation is mathematically important and will be used as the appropriate measure of variability when mean is an appropriate measure of center. Like the MAD, the standard deviation is large when the data set is more spread out, and the standard deviation is small when the variability is small. The intuition you gained about MAD will also work for the standard deviation. The more variation a distribution has, the greater the standard deviation. A more compact distribution will have a lesser standard deviation. In statistics, an outlier is a data value that is unusual in that it differs quite a bit from the other values in the dataset. Outliers occur in datasets for a variety of reasons, including, but not limited to, errors in the data that result from the data collection or data entry process, results in the data that represent unusual values that occur in the population. Outliers can reveal cases worth studying in detail or errors in the data collection process. In general, they should be included in any analysis done with the data. A value is an outlier if it is more than 1.5 times the interquartile range greater than Q3, or more than 1.5 times the interquartile range less than Q1. It is important to identify the source of outliers because outliers can impact measures of center and variability in significant ways. The box plot displays the resting heart rate in beats per minute, BPM, of 50 athletes taken 5 minutes after a workout. It appears that the maximum value of 112 beats per minute may be an outlier. Since the interquartile range is 14 beats per minute and Q3 plus 1.5 times the IQR is 97, we should label the maximum value as an outlier. Searching through the actual dataset, it could be confirmed that this is the only outlier. After reviewing the data collection process, it is discovered that the athlete with the heart rate measurement of 112 beats per minute was taken 1 minute after a workout instead of 5 minutes after. The outlier should be deleted from the dataset because it was not obtained under the right conditions. Once the outlier is removed, here are the new box plot and summary statistics. The mean decreased by 0.86 beats per minute, and the median remained the same. The standard deviation decreased by 1.81 beats per minute, which is about 17% of its previous value. Based on the standard deviation, the dataset with the outlier removed shows much less variability than the original dataset containing the outlier. Since the mean and standard deviation use all of the numerical values, removing one very large data point can affect these statistics in important ways. The source of any possible errors should always be investigated. If the measurement of 112 beats per minute was found to be taken under the right conditions, it should not be deleted so that the data reflect the actual measurements. If the situation cannot be revisited to determine the source of the outlier, it should not be removed. To avoid tampering with the data and to report accurate results, data values should not be deleted unless they can be confirmed to be an error in the data collection or data entry process. To compare data sets, it is helpful to look at the measures of center and measures of variability. For example, let's compare the number of seconds it takes football players to complete a 40-yard dash at two different positions. First, we can look at a dot plot of the data. to see that the tight end times do not seem symmetric, so we should probably find the median and IQR for both sets of data to compare information. The median and IQR could be computed from the values, but can also be determined from a box plot. Here are the box plots for each dot plot. This shows that the tight end times have a greater median, about 4.9 seconds, compared to the median of the wide receiver times, about 4.5 seconds. The IQR is also greater for the tight end times, about 0.5 seconds, compared to the IQR for the wide receiver times, about 0.25 seconds. This means that the tight ends tend to be slower in the 40-yard dash when compared to the wide receivers. The tight ends also have greater variability in their times. Together, this can be taken to mean that, in general, a typical wide receiver is faster than a typical tight end, and the wide receivers tend to have more similar times to one another than the tight ends do to one another. Thank you for watching video 4 of 4 for this unit on one variable statistics.